Our question is a certain patient took off a kind of medicine with an initial dose of 200 mg. The metabolism of the drug in the human's body follows the law of the exponential disease. 4 hours later, the drug concentration in the blood drops to the 120 mg. And first A is rate of the mechanical expression of the remaining of the amount of the drug dt mg in the body is verified with the time t hours. Question B is calculate how many mg the drug concentration in the blood with the drop to after 8 hours.
For the step 1, we need to establish the differential equations. We need to see the process of the using the first order kinetics, where the rate of the concentration change is potential to the current concentration is the dc over dt equals to negative k over c. Ct is drug concentration at the time of t, k is the dc rate constant. As well, we need to separate both the variables. We need to rewrite to isolate the variables c and t. If the dc over c equals to the negative k multiplied dt, and step 3 we need to integrate both sides. That's a very important rule for the ODE. Integrate to slope of the c over t is the integrate 1 over c dc equals to negative k integrate the dt to get the Ln modulus of the c equals to negative kt plus c. And step 4 is the pointed to slope of Ct. Convert the correlation equation to its exponential form is the Ct equals to Ec multiplied E negative Kt, and let the C0 equals to the Ec because the initial concentration at the t equals 0 is Ct equals to C0 E negative Kt. Step 5 is to apply the initial conditions at the t equals to 0. We need to subtitle t equals 0 and c equals 200, so the is 200 equal to c0 e 0 is to get the c0 equals to 200. So that the module simplified is the ct equals to 200 e negative kt. And step 6 is determine the k using the t equals to the 4, c equals to 120. Subtitle the second data point is the 100 equals to negative 200 e 4k. 94k. Get the is negative 4k divided 120, and 120 divided 120 to get 0.6. And take the natural log duration is the negative 4k equals to Ln's module 0.6, and k is the negative 1 over 4 Ln module 0.6 is the 0.12 hours, negative 1. And that's why we need to rewrite it in fractional power forms. We need to express the exponential term using the observer dc to the ratio of 3 over 5. Why this is the 3 over 5? Because this 100 divided 200 is 3 over 5. And so the Ct equals to 200 multiplied e negative t over 4 linear module of 3 over 5 over 3. 5 over 3 is the equals to, use the formula is the E F negative Ln's module of x is the 1 over x. So the last answer is the, for this the simple rules get the equals to 200 multiplied 3 over 5. The square is the t over 4. So for the others two, problem B and C, we need to first get the problem B. Problem B is to calculate the drug concentration after the 8 hours. So first thing we need to compute the square of 3 over 5. So it's 3 over 5 the square is means the 9 over 25 equals the 0.36, and use this formula to 0.3 multiply the 200. It's the 72 mg multiplied L. So do you